Hello everyone, my name is Alana and I am a part of the Innovyze team here in Asia Pacific. Thank you everyone for joining us today for our webinar discussing how an upfront investment in sewer flow monitoring deferred forecast capital expenditure, a project brought to us by Stantec and East Gippsland Water. While we wait for a few more people to join, a little background on our company for those that are new here. At Innovyze, we have a mission to empower water professionals around the world to successfully create, manage, and maintain their water services. We are the global leader in water infrastructure data analytics software, and we aim to provide innovative decision-making software solutions for lasting customer success. So we have over 45 plus years of experience, over 3,200 clients in around 60 odd countries, and that includes servicing the top 10 cities in Australia. Our main product families in Asia Pacific are asset management, storm and flood, sewer, water supply, operational analytics, and now artificial intelligence. During today's webinar, we encourage you to ask any questions you have along the way in the questions box to the left of your screen. Any questions will be answered either during or after today's webinar by Jane or Patrick. You will also have an opportunity at the end of the webinar to ask questions also. Before we get going, it is my absolute pleasure to introduce you to our host for today. Guiding us through this collaborative project between Stantec and East Gippsland Water will be Jane La Nauze from Stantec. Jane is a chartered professional engineer at Stantec and is the group manager for water in Victoria and South Australia. Jane has extensive planning experience in the water industry. She has undertaken numerous model builds, calibrations, and master plans for water, recycled water, and sewage networks. She is experienced in the use of water supply and sewage hydraulic modelling software. Jane's skill set also includes integrated water management and strategic planning, including recently assisting Melbourne Water in developing Melbourne's 50-year sewage strategy. She enjoys working collaboratively with her clients to better understand the issues they face and to ensure mutual success. We are also joined by Patrick Bonk, who is Innovyze's Asia Pacific team resident sewer hydraulics engineer, with the role of software solutions lead. Patrick has a master's in engineering design of sustainable infrastructure and joined Innovyze in 2014 with a focus and passion towards the emergence of operational analytics decision support tools and software advancements within the context of smart water systems. With all of that being said, please take it away, Patrick and Jane.
Thanks, Alana. Good morning, everyone. This presentation aims to really highlight the great work and project success by Stantec and East Gippsland Water. The success of this project helps indicate and communicate the value of prioritizing this type of program to inform capital works and network operations. So for management considerations, this is really worthwhile case study to speak to. How do I get the most out of the models we've invested in? What is the value of a flow monitoring program when utilized with a hydraulic model? And how do we get these models to be more fundamental decision support tools within our organization?
Yeah, hi everyone, it's Jane here as well. I guess this project was significant for both Stantec and East Gippsland Water in that we helped East Gippsland Water to defer a significant amount of capital investment, which was around 15% of their annual capital budget. And I guess the other point that was really important through this was the level of collaboration between our two organisations, which resulted in the outcomes. So today, Patrick and I will be walking through, I guess, the project as a whole from where we were in the past and how we came to the decision to invest in flow monitoring, resulting in an approved product and model for use in master planning and capital program development. And then also, I just wanted to touch on a bit of a sensitivity analysis we did around climate change, as this is obviously something that we're all grappling with, how we incorporate this into our planning projects. So this is just one option to consider. And then we'll wrap up with how we achieve success and where to from here.
And then also throughout the presentation, we'll touch on aspects of the software that could be used for further operational benefits and project efficiencies and ways in which you can save time on the project itself.
Yeah, so I'll start with, I guess, what we've been doing in the past and how we got to this point in time. So just a little overview. East Gippsland Water are one of Victoria's regional water corporations, stretching from Bairnsdale to Mallacoota in Far East Gippsland, servicing around 45,000 people. And the focus of this study is two of East Gippsland Water's largest towns that they service, Bairnsdale and Paynesville. And I guess these towns are located on the land of the Gunai Kanai people, and I just wanted to pay my respects to their elders past, present and emerging.
Thanks for that.
So just looking at a bit more in the details of Bairnsdale and Paynesville. So Bairnsdale's on the left there and Paynesville on the right. Bairnsdale services around 6,000 connections and Paynesville around 3,000. Across the two networks, there's a combined around 43 pump stations, so heavily reliant on pump stations in these networks. And also Paynesville is located next to the Gippsland Lakes there, and so grapples with things like groundwater levels and infiltration and inflow and infiltration. So I guess, you know, from the beginning, why do we have a model in the first place? Generally, water corporations in Victoria roughly model, you know, update their models on a 5-year cycle to align with the development of capital programs to feed into the pricing submissions to the Essential Services Commissions. And this is, you know, used as an important planning tool to assess compliance and to plan for infrastructure. And I guess having the tool is up to date is important to allow that the right investment goes into these capital programs and expenditure. So I guess, Patrick, from your perspective, what else do you see these hydraulic models being used for in the industry?
Yeah, there's a lot of progression that's been made in the technology as well as by the practitioners of the software itself. So models are more so than ever fundamental decision support tools for a wider variety of use cases. So from system planning for near and long-term understandings of your network, where you could look at both condition and capacity for your decision making, and then things like water quality modeling, modeling sewer spills, and now the software is reaching a point where it's depended on by operations teams for operational management, for incident management. So if you have a pump station failure, a gravity sewer blockage collapse, that can be applied. For contingency plannings based on incoming events to your network. So if this pump fails, what are the options if that failure occurs? And then risk identification for those incoming events as well. So to prioritize high consequence of areas in your network. And then furthermore, the reliability of the models has also reached a point where they're trusted for crew safety when in particular live sewers, to be able to look at that forecast event that's going to be approaching the network. So there's really interesting things happening in this space, and a lot of progress has been made. So we're excited about this particular project because it really demonstrates the value of that upfront investment in the flow monitoring to build your models and your studies from.
Yeah, great. So I guess touching on where we've been. So we've actually been on this journey with East Gippsland Water since 2013. And obviously the project hasn't continuously worked for that long, but that's when we started. We updated the model for the Bairnsdale catchment back in 2013 and the Paynesville initially in 2017. So when we set up these models initially, we had limited data available. So we applied theoretical-based residential sewage loading rates to the model, and this we used the water consumption data with a return to sewer factor and adopted one value across the whole catchment. We used typical wet weather response parameters, and the reason for this was we had limited SCADA data and so weren't able to see necessarily all the in-sewer response to rainfall. We then used these models to analyse the existing and future system performance and develop a 20-year infrastructure master plan for the catchments. However, this then led to, I guess, a significant forecast in expenditure, and there was prediction of spills, which was inconsistent with East Gippsland Water's operational understanding of their networks. And so this sort of raised, I guess, alarm bells about, well, how confident are we in these models as a tool, and how are we going to use them to come up with our level of investment if East Gippsland Water aren't confident in the outcomes.
So it sounds like you had some SCADA data to validate the model. Can you expand on how you had a low confidence in this particular data?
Yeah, sure. So I guess across the two catchments, we had limited SCADA data. So it was located at key pump stations and not necessarily capturing the flows across the whole network. So this limited our ability to, I guess, confirm flows across the whole catchment. And it also the SCADA data was actually, I guess, recorded in inconsistent time steps. And so we had less confidence in, I guess, the overall data and the ability to look at that more granular level of flows and into a response to wet weather or, residential sewage loading rates.
Okay, so that was a part of your decision to invest in the flow gauging? Yeah,
absolutely. So I guess the limited data, coupled with the fact that the models didn't reflect East Gippsland Water's sort of understanding of their networks and how they perform, led to this decision to invest. So I guess, we drew on our experience using models to help East Gippsland Water understand what you could do to improve the model accuracy. And so we headed down the path of investing in temporary flow and rain gauge monitoring. So I guess the purpose of this was to get that better flow coverage across the whole network and at key locations. It allowed us to have capture in-system flows, and what I mean by that is not just at pump stations, but also in large trunk sewers. We were able to capture flows in those areas. It allowed for better quality data, so consistency, having the data captured all at the same time and for the same time steps. And lastly, having that smaller time step gave us a greater understanding of the immediate and long-term response to wet weather. So I guess following that decision to invest, we worked with East Gippsland Water to develop flow and rain gauge monitoring plans. So we did an analysis across the network to capture, key assets and locations. Then East Gippsland Water engaged a contractor to undertake the flow monitoring. And during that period, Stantec analysed the data to ensure that we were getting the right level of quality and that there was consistency in the data and that we were capturing enough data to be able to undertake both dry and wet weather calibration. So to that effect, we initially had the monitors in for 6 weeks, but then subsequently some large rainfall events occurred just after that period. So we ended up extending the capture out to 10 weeks.
So what are some of the tips for selecting flow monitoring locations for this particular study?
Yeah, sure. So I think for us, it was really important to ensure we had a good distribution, a spatial distribution of monitors so that we were capturing the whole of the network and not just some key locations. We wanted to ensure, we want to ensure that the monitors are located at suitable locations. So you don't want to have a manhole with lots of incoming sewers necessarily and get turbulent flows. So considering what's happening, and sometimes when they're located too close to a pump station, the pump effects impact, I guess, the ability to capture the data. And you also want to make sure that you're getting enough flow. So the flow monitors are better, they record more accurately the larger the flow is. And then I guess the last thing is just to make sure you're capturing your key assets as well so that you're confident in how they are performing in the model.
Sounds good. And then we'll lead into when you have a successful project such as this, how do you communicate this type of project to an organization internally? kind of tips could we provide here?
Yeah, I mean, I think it's sometimes hard. Like, you know, we've now got some proof that helps demonstrate that to your managers. But I guess I think there's a real important piece around ensuring your managers, or, you know, whoever's making the, I guess, decision to invest, really understand what we use the hydraulic models for. And I think often they just sort of thought, oh, that's just a tool for this and that, but really understanding why. And I think there's some important points, you know, around, are you using your hydraulic models to demonstrate compliance with statutory obligations? And then, are you using this to support the development of your capital programs? So those real fundamental things that are then, you know, critical to your business, and using it, you know, making sure people understand this is a key tool to making those decisions. And then also then, because it's, you know, fundamentally used for those decisions, that the tool needs to be of good quality. So, you know, the sort of cliche modelling saying is rubbish in, rubbish out, but it's, I mean, it's absolutely true. And when you don't have good quality data, you tend to be more conservative in your approach, which probably leads to overinvestment because you're being more conservative in your approach to planning.
Yeah, that's really good insight. I would say from a software perspective, say if there's an aspect of the application you've already been able to understand that it's what you need for your particular project. What you want to do up front is understand decisions in organizations aren't made alone. So you want to be able to pull in your budget decision makers, your technical decision makers, as Jane touched on, and procurement, so that they could procure the software up front to go along with the project. And then you also want to be able to relate the software, what it's doing, as well as what the problem the project is solving, to the overall needs of the organization, and just be able to, depending on who you're speaking to, understand that there's operational benefits, there's value benefits, and you want to be able to relate it back to the overall strategic goals and initiatives of the organization.
Yeah, I think that's a really good point.
Yeah, as well, just to add to that, you know, if you're speaking to operations, they're going to be interested in improved responsiveness and efficiency and cost savings. And then if you're looking, if you're speaking to asset management, or people are interested in asset performance, then all of a sudden it's a conversation around reliability, minimizing risk, and the cost over a particular asset's life cycle. So yeah, to just work within the language of the person you're communicating, and the way they view the problem as well. So
cool. Yeah,
if you want
into the
improving model accuracy, yeah, some more of the project details.
Yeah, great. So I guess, yeah, we've sort of touched on the project in general, and now we're going to go into a bit more details around some of the actual modelling aspects. So basically, more recently, we did an update in 2018 for both the Bairnsdale and Painesville models, and these were built in InfoWorks ICM. So we went through the process of ensuring these were up to date in terms of GIS, so in terms of all the assets, and also removing any decommissioned assets that have happened since the last updates. We input only the latest operational information for things like pump stations, and then we ensured that the population and the properties in terms of subcatchments was up to date based on the latest billing data. So as I touched on, we went through the period of collecting flow monitoring data, so over about 10 weeks. And basically through that process, we reviewed the quality of the data, and we're able to capture over 90% continuous and concurrent data for depth, velocity and flow, which was a vast improvement of where we came from before, I guess, with the SCADA data. We're also able to achieve a flow balance, and by this I mean that your downstream monitors have a greater flow recorded than your upstream monitors. And then here we're showing a depth and velocity scatter plot, which shows a good relationship between the depth and flow of this flow monitor. And yeah, so that gives us confidence that the quality of the data being recorded is accurate, I guess, or good. And we also, I guess, throughout that period observed a good in-sewer response to rainfall, which then gave us confidence that we'd be able to calibrate the model to wet weather flows as well.
So I wanted to take this opportunity to relate time series database technology to this particular project and some of what Jane was speaking to. So time series database is within InfoWorks ICM or ICM1, and it's also the technology that underpins ICM Live. So in short, it's a performance database. It allows you to connect directly to your telemetry and SCADA data. So earlier in the project, Jane mentioned that they had done some analysis on that type of data. So you'd be able to directly pull that into your model. And then once it's connected, you have the connection established where it'll automatically update. So you no longer have to be manipulating outside spreadsheets. You're able to establish that direct connection. So I'll just give an overview of what TSDB, the time series database, looks like in the software. This first viewpoint, let me just get that. Okay, so as you can see here, we're within InfoWorks ICM, and here's a network view. You can see within the model's GeoPlanet a simulation that has already been run, and you can click directly on a sensor location within your respective network. And then in the model, we call this the time varying data connection, where from the asset within the model, like whether it's a pump, a pipe, a manhole, a catchment, we're able to pull in our measured data, so flow, level, velocity, pump on-offs, and attribute it to the asset itself. So you'll have access to your model versus your measured data based on those direct connections. And the network view ties the data connection to the asset itself. So if you've done a flow program similar to this particular project, we can connect directly with TSDB to say ADS environmental, like directly to their systems through an open API. Or if you have an Excel file, like a spreadsheet file from say 2013, you're able to bring it in to the TSDB. So on the right, you're going to see the time series database, and this is what it looks on the back end. So for this particular database, we've mapped multiple data streams, so flow, level, and velocity. The data streams can be mapped from multiple data sources, and for this example, we'll view back to say, you can see there it's back to 2017 or 2016. So you can imagine if, say, you've done a study in 2013 or you've done a study currently this year, you can have all that data in a central point of truth. So so if you have, sorry, let me gain my thoughts. If you have TSDB in place, the value of your models themselves won't depreciate as rapidly. So the investment you put into the flow monitoring and projects of this nature, you can continue to use them to inform your network because your models are up to date. And then, as I mentioned, this is the technology that underpins ICM Live. So you can take in forecast rainfall data, and by having your models utilized by operations or field response teams, you're making even better use of projects of this nature where you've invested in that flow study, in that calibration work. And then just fundamentally, there's kind of operational benefits to reduce errors and save time and eliminate manual steps and to simplify your workflows. So there's a bunch of kind of added benefits in addition to the kind of the overall big picture.
Yeah, and I think, I mean, just thinking about our project as well, you touched on it about having the different data sets from different flow monitoring periods in the one location and not having to remember where you've stored that information on a server somewhere. Yeah, looks to be useful.
Yeah, that central point of truth, and again, like you'll be able to map directly to the SCADA data as well from your particular model.
Yeah.
So yeah, it's really helping progress the caliber of this technology. So we'll go back to fundamentals and cover dry weather flow calibration. Did you want to touch on how that was done for this study?
Yeah, sure. So I guess I mentioned earlier that in our previous studies, we used a single residential sewage loading rate across the whole catchment based on water consumption data and a return to sewer factor. So by having, I guess, the flow monitoring data, we had a better spatial distribution of flow across the catchment. And this provided us with a more granular understanding of the sewage flows of various customer types and resulted in us being able to apply a specific residential sewage loading rate per flow monitoring catchment rather than having that one system-wide. And I mean, that table there just demonstrates the various values that were adopted across the network. And just here, I guess, just further to that, on the left is the 2013 results at one location in the model, and the 2018 results on the right for the same location. With on both graphs, the green lines are the modelled results. And as you can see that on the right graph, we're getting a much better match in our modelled results with our observed data. So by having this spatial distribution and applying different sewage loading rates across the catchment, we've been able to improve the accuracy of our dry weather calibration.
Fantastic.
Yeah, and then I guess following on from that, the dry weather calibration obviously underpins your wet weather calibration, so it's important to have that right to start with. And then I guess, you know, the important thing to point out here is that we've been able to capture that real instantaneous response to rainfall in the observed data, which has allowed us to then be more I guess, specific in the wet weather parameters we've applied across the catchment and not just using catchment-wide values. We've been, you know, representative to the different flow monitoring catchments and allowed us to replicate that in-sewer response to rainfall more accurately. So having that smaller time step from the flow monitoring data has been, yeah, a real benefit.
Amazing. So there's another tool in ICM from a software standpoint that will help with the precision and the ability to save time on the iterative nature of your scenario building, as well as sensitivity analysis once your model is actually calibrated. So what I'm about to kind of go through is called ICM Exchange. A lot of people in the industry would be aware of it. They're already using it. I wanted to take this opportunity to just show the benefit of Exchange relative to a project like this. So Exchange provides existing ICM users. So as long as you're using ICM, you could purchase a license of Exchange as an upgrade. So it gives you the ability to auto model updates from your asset data for scenario analysis and sensitivity analysis. So Exchange is typically used to run batches of simulations with changes coming from outside the software. So you're able to edit and update query database tree objects, create, copy, and delete aspects of your database. In this scenario, we'll see how actual network scenarios are created. So for this particular example, we've just triggered a particular script to run in the background. So the mouse that you see moving around is actually to just activate the particular script itself. And then you can see the script initializing. That cursor is just moving so that once the simulations kick off, you'll be able to see the automated nature of this is a script kicking off this. It's developing the scenarios right now. It's initialized, developed the scenarios, setting up the simulation, and now it's kicking off the sims. So the beauty of ICM is you're able to offload your simulations based on different scenarios for this, you know, when you're doing that optioneering part of your analysis, or say you're adjusting calibration parameters in your analysis. You could literally just adjust it in the script itself and then kick it off, and you could run these multiple simulations, you know, in the evening. So this is a real simple model just for the benefit of a particular example. There's a particular pump station, and for this analysis, we're just looking at what capacity of the pump station will prevent a particular prevent a weir from overflowing. So we've gone and run probably 20 or 30 different pump capacities for this particular scenario. And then as these simulations finish, it's actually going to generate an Excel kind of output, which helps you pick the ideal pump station for that particular scenario. So here, the script, this is all automatic, no hands. And so there, the scenario has gone and selected the pump station with the lowest discharge before the weir actually stops spilling. And then there, it's automatically generated my Excel file, or my spreadsheet file, I should say. And it's telling me here's the minimum increase in the downstream pump rate to prevent the spill. And then I'll go back into the software. This is all automatic. You'll be able to see that your completed runs are there. And again, those are simulations that could have been kicked off on a central server or kind of more of in a work group manner. And then you just drag and drop the example or the optimal example to see that no more spilling occurred. So it's a really kind of beneficial tool to, again, from an operational benefits and a project workflow standpoint, to help you save time, to eliminate a lot of manual steps in your modeling, to reduce those errors in your workflow, and to be more precise with your actual analysis. So Jane, did you want to cover kind of some more of the system performance?
Yeah, absolutely. So I guess following on from once we'd calibrated the model, we then wanted to undertake the system performance. So the EPA's Victoria's containment standard is to ensure that all flows resulting from an 18.1% annual exceedance probability rainfall event are captured within the system. So as many of you would be aware, the Australian Rainfall and Runoff has recently been updated, and I guess for sewer modelers, this has made our life a bit more complex with the number of temporal patterns and included, and determining our critical storm is a little bit more onerous. But so we went through the process of determining our critical storm, and we generated the rainfall using the Innovyze, I guess, inbuilt function to pull through the rainfall data. And then from that, we analysed the extent of surcharging and performance to determine our critical duration storm for both catchments. And a bit of text there, but that table essentially is saying that, you know, in our previous studies, so in 2013 and 2017, we predicted network spills. And then in our updated models, we didn't. And so this is basically, I guess, reflecting EGW's understanding of the network operation. So it increased the level of confidence in using these as planning tools, and it also reflects, I guess, the level of investment we put into this has resulted in a good outcome for East Gippsland Water. I think, just lastly on that as well, I guess we also, as well as the existing performance, we then applied growth to both catchments, and then did the forecast growth into the future, and then assessed the system performance for the networks into the future, and analysed the, I guess, performance of them. Yeah.
Okay, so another, to build on what Jane was speaking to, Inforix ICM has the AR&R rainfall generator in it. So if you're not using this function within ICM, please start. So it's essentially allows you to create the Australian rainfall and apply it to your model. So if you can see there, we're selecting, it says 2016, but it is up-to-date data that it's pulling down from the BOM. So you add a new rainfall event for this particular example, the AR&R 1% 60-minute storm. So we're just going to set it up with one particular pattern. and you select your storm generator. As you can see, the map of Australia opens up for you to be able to select the location in which you want to pull your data down from. So if you're connected online, you'll see the map. But if you're not connected, the option exists to add from a particular file that you have already downloaded. So for this example, we'll zoom into Brisbane and select the location of the airport. And then from there, once we have a location, we download the BOM IFDs, so rainfall depths, and the data hub temporal patterns. Okay, so at this point, you can see the AEPs and durations populated. There's 10 ensemble patterns that are sitting in the background for each of these AEPs and durations, and that touches upon what Jane mentioned with it's making the analysis itself more rigorous. But fortunately, we have this tool to kind of automatically pull down the data for that particular location. And then for this example, it's a 1% and a 1 hour, a 2 hour, and a 3 hour. And you can see the 10 ensemble patterns are there. So from that summary report, you can confirm what you've actually downloaded. And then once within the rainfall generator, you'll have the option to select and deselect the storms you require for that particular analysis. So you're just not pulling down too many return periods for that. It's essentially for the ones you need. And then you'll click OK, and the rainfall events will be available for you to drag and drop into your model. So again, that's another way to achieve operational benefits just within tools that are in the software. This tool was built to align with the AR&R 2019 specifications and methodologies, and the implementation itself won an innovation award in both 2017 and 2018 with Stormwater Queensland and Stormwater Australia. So I guess the sewer space gets to benefit from the great work driven by our stormwater team.
Yeah, I remember having to manually go and find the location and things like that. So I'm probably showing my age, but it's very helpful too.
Years ago.
So yeah, coming back, I guess, to our case study. So after we completed the system performance, for Paynesville anyway, so we did that future system performance, and it resulted in no spills in the future. So this is where we've come up with this $1.5 million capital investment deferral by the fact that, you know, in that whole 20-year forecast, we don't have any spills in the Paynesville network. So that's fantastic, and has really, you know, I guess, given us that return on investment. And also in Bairnsdale, the future, there are some network deficiencies, but the immediate ones that we were previously forecasting are now deferred into the future, which again has just given us more confidence in these models as a planning tool.
Wonderful. And then you also completed sensitivity analysis.
Yeah, we did. I just thought this was an interesting one, I guess, to just share with the industry, in that, you know, there's a lot of large uncertainty, I guess, related to the impact climate change will have on sewage systems, and in particular, the intensity and duration of rainfall events. So East Gippsland Water asked us to investigate an option to look at how we could assess climate change into the future. So for this project, we used the methodology that's outlined in the Australian Rainfall and Runoff 2019. And so basically, essentially, we take our critical duration storm and we adjust the rainfall. So for this methodology, it includes a 5% increase in rainfall intensity for every 1 degree of temperature increase. And we also used a representative concentration pathway of 8.5, which assumes that there's no effort made by humans to reduce emissions. We then, instead of testing this against our 20-year infrastructure scenario, we actually forecast this out a bit further into the future to the scenario which we have as being our full development scenarios for both the catchments. So when all the known developments are fully developed. And basically for this, it did indicate that the model results are worse. But for Paynesville, we're still not seeing issues. So it sort of gives us confidence that the system has capacity to cater for the future, and we don't need to factor in necessarily any impacts of climate change for Paynesville at the moment. So yeah, just one methodology that is out there and gives you some, I guess, tool to work with around climate change.
Yeah, it's really good to know you applied that methodology for the study. Jane, did you want to give a bit of a recap on why you thought this project was successful?
Yeah, for me, I mean, I think really the success of this project came down to collaboration between East Gippsland Water and Stantec. I think by having open discussions and knowledge sharing, we'll basically, built a level of trust between our two organisations, and that allowed us to draw on our, I guess, extensive experience in hydraulic modelling and planning, and also allowed for East Gippsland Water to contribute all their knowledge of their networks and their understanding, and how we could bring those two sort of, I guess, skills and understanding together to drive a better outcome overall for the project.
Great. We'll just finish off by kind of recapping the outcomes.
Yeah, I mean, so yeah, I've touched on the collaboration, which I do think was critical in this project to, I guess, driving the outcomes, and also the decision to invest in flow monitoring. By having, I guess, the more accurate data and better spatial distribution and more granular time steps, we've improved the confidence in using the hydraulic model as a planning tool. And it's also increased East Gippsland Water's confidence in using these tools as well. Yeah, and we've recently touched on, the methodology again for assessing climate change, and I think that's, something that I'm really interested to see what the industry does in this space going forward, and how we continue to work through that. And yeah, just lastly, that upfront investment has really resulted in a great benefit for East Gippsland Water, and yeah, I look forward to seeing where they go with this next in terms of, some of their other networks, and being able to help them plan for the future.
Yeah, that sounds good. Thanks for doing this today. This exercise or presentation resulted in, I was able to see Jane's presentation on this particular project at Ozwater, and I was really impressed with the effectiveness of the study itself, and the overall findings and the successes, and was inspired by the collaboration and the use of the software itself. So I'm really grateful for you taking the time to present this project with us this afternoon, or I should say this morning. And yeah, so just to take the opportunity to recap what was covered from an application standpoint. We have ICM1, InfoWorks ICM, and ICM Live. So if you're not familiar with ICM1, it's a streamlined version of InfoWorks ICM that we've come out with. So if you're a small team, a small council, if you have a small project for, as a consultant on the behalf of your client, ICM1 has a lot of the main features of InfoWorks ICM, but it is streamlined so that it isolates to a single user. So with InfoWorks ICM, you're able to do heavy lifting by offloading your simulations onto a central server. And there's a couple other ways in which we streamlined it. But if you are kind of a smaller council or regional council or a utility that has a particular project, give thought to ICM1, because you'll also be able to unlock the TSDB and ICM Exchange. They're licensed separately, but they can both, I don't know if bolted on would be the word, but apply to ICM1 and InfoWorks ICM. And then a lot of us are familiar with ICM Live. So the link between InfoWorks and ICM1 to ICM Live would be the TSDB technology. ICM Live essentially builds on your existing InfoWorks planning model. And then that TSDB technology is there, and then you're going to be able to run forecast scenarios to look at scenario planning, incident management, risk assessment based on those forecast events. So this is now models are in the operational space. ICM Live has a simplified interface for operators to be able to interact with. But I just wanted to take the opportunity to just recap the technologies we did discuss in this presentation. And then please reach out with any particular questions, whether it was on the software itself, how do you have access to the TSDB, the time series database, Exchange, as well as something like ICM Live. If your planning models are calibrated, even in the last couple of years, you'd be able to upgrade to something like TSDB. And once those live connections are established and you start bringing in forecast rainfall from a source like the Bureau, you're closer to a live model, whether it's for short-term planning or kind of near-term like incident response to from an operation standpoint. So I just wanted to allow any particular questions to come in. There's been a few as we've been presenting. Jane, do you have time for just a couple questions?
Sure.
Okay. Let me just see. They're coming into the session. Did you do an II analysis in addition to the model calibration? For this
We did. Yeah, I didn't specifically mention that. Yes, but we did do that. And I guess for East Gippsland Water being part of Victoria, generally, I guess we're following the Melbourne Metropolitan Sewage Guidelines. So yeah, we followed that methodology to do the II assessment. Interestingly, yeah, it probably didn't give us necessarily the results we expected in Paynesville, but yeah, something still working through.
Okay, and the next one would be, what are the next steps with East Gippsland?
Yeah, sure. So, yeah, so I mean, investing is still, something that still requires us to work through with East Gippsland Water and management. So it's not just become a given for them, but this has definitely helped demonstrate the benefits. And I think for a regional water corporation, it's also about, is it worth investing in some of your smaller towns, or is it, your larger networks? So it's about, doing that analysis on where they're going to get that return on investment. So that's what we're working through with them now.
Okay, awesome. Another one was, are those scripts available? I would assume they're talking about the scripts for ICM Exchange. I'm not exactly sure on that. Shout out to, special thanks to Tom Godman in the UK and Nathan Gertz for writing those scripts. I'll have to check with them if they're available, and then we can figure out how to kind of commercially make those available as well. But chances are, reach out to me and I can figure out a way to get them in your hands, as long as you have ICM Exchange to be able to run those particular scenarios. And then once those scripts are set up, then you could apply it to, instead of the capacity of the particular asset to prevent an overflow, you could just provide it to your calibration parameters when you're doing that initial calibration to come up with some scripts. So that's a good question. Is the database the same for the base model and the live model? Oh, that's a good one. Yes, it's the same technology. So if you have aspirations of ICM Live, you're essentially taking your ICM model over, you're opening it in ICM Live, and then it's the same time series database. TSDB is available in ICM1, Infoworks ICM, as well as ICM Live to throw enough product names at you. So I think if you have any additional questions, if you're typing them into the dialog box at the moment, we're going to be able to receive those questions. We're also going to send out a follow-up survey with your thoughts on the presentation and any follow-up questions that you could potentially have about the project for Jane and her team, as well as if it's software related, please reach out to myself or Jane directly, or just enter your questions in the follow-up survey. So thanks everyone for joining. We made it in well under the hour, and I really appreciate everybody's time today. Thanks so much, Jane. It was great to have your project and your expertise, and to be able to proudly present on your accomplishments with East Gippsland.
Thanks, Patrick.
Okay, take care, everyone.